This video, we will be solving our first CAD test in NX. Okay, so we have the general note that first thing is that we need the part modeling to be parametric. That is, it should be changeable. Then the part should be non-hybrid, and we have the general wall thickness as 3 mm. So the part thickness is 3 mm, and we only need to work on the part file that is provided to us. And this is the part, the data that have been given, the A surface and the environment and all of this. So this is the part that we will be working on. So the input is A surface, that is number 1. We have the A surface or a part, then the environment part, that is the surrounding. Then we have the main tooling direction, the MTD. The brown color line that you can see here is the main tooling direction. Then finally we have the master section that gives us the idea of the profile and the B-side features as well. So the output required is to create a closed volume with the provided A surface as per the given section. So we just need to carry on with the A to B surfacing according to the master section that have been given to us. So here I have the part and the environment part as well. Can see on the part navigator as body 1 and body 2. So this is the non-timestamp geometry, that is our master section. So we'll start off with the feature group. The first thing is that I will create an environment for the environment data, and I will keep it in this one. You can either create a assembly and make them as separate parts of an assembly, the environment and the main body part. But in this one, I am just using a feature group. In the other CAD test, I will be doing it with taking the part as assembly, the environment and the body as two different parts of an assembly. That is a much better approach. You can carry on in this manner as well, but the other later part is more preferred. Okay, so here we have the body, and I moved it to the A surface here. So unsewing and removing all the parameters will create one body for each face, and then we can sew them up within our tolerance limit to get all the continuity and a smooth surface. Now the B surface. Okay. First I will be creating a plane along this master section so that we can have a sectional view to check the part thickness and to check that the profile, how the profile looks, and also to see if we are proceeding and creating the part in accordance with the master section that is provided to us. So that is why we need to have a sectional view on the master section itself. So this is the sectional view at the master section, and as you can see, the part thickness is not even. It is even on these two sides, but then there is a gradual change in between. Okay, and the general thickness is given as 3 mm, but we will measure it at every point of this master section. Okay, so let's measure the thickness. It is 2.8 mm on this side. So I will be taking 2.8 mm offset first, like this, and then I can clearly see how the master section, the thickness changes gradually from one side to the other. So what we need to do is we need to trim this. I will trim it at this point. Okay, trim it using this plane like this. Okay, and then I will create another surface. First measure it. Here the thickness is 3 mm, that is according to the information that have been given to us. So I will take a 3 mm offset here, and then again I will trim it at the edge where it is even, like that is this point here. I will take this point and create an inferred plane, and then trim this surface, this offset surface, like this. And then we can simply use through curves or Surface Studio to create the missing patch like this. So as you can see, it is completely according to the master section. It lies on the master section as itself. And then taking the offset of the other side, let's measure the thickness. It is 1.5 mm. So taking 1.5 mm offset here. Okay, again the thickness is varying. Let us see. Yeah, so the thickness is varying, so we need to do the same thing that we did for the previous surface. I will measure the thickness here. Okay, so 1.7545 is the thickness that it is showing. Let's measure it on the other side. It is 2 mm. Let's do that. Again the thickness is varying for this side as well. Okay, so let's measure the distance at every point where the thickness is uniform. So here the thickness is 2.2 mm. So let's take a 2.2 mm offset. Okay, so as you can see, it is at this point. It is just lying on the curve here. So I will take a plane and trim this offset. Okay, so now using this edge, we can use the law extension to draw the surface or create the surface in this direction of the master section. Or you can use the sweep surface command as well for this one. So hide the surface that we use, the edge of the surface that we use, because we don't actually need this surface. We only need a reference to create the surface at this point. Similarly, we will proceed for this one as well. The thickness is 2 mm, so 2 mm offset. Then again I will create another datum plane here at this point or this corner, and then I will trim the surface so that we can use the edge again in the similar fashion like this. So now we can use this edge to create a surface according to the master section, using the master section as the directional vector. Extend it all the way through because we will be trimming it. and then hiding the surface that we originally used. Okay, so as you can see, it is according to the master section, completely on the line. And then we can simply create the missing patch in the similar fashion. Using the law extension like this. So this was the profile, and this is the how the surface comes out to be. Okay, it is not even, but we don't need to be bothered because we will be taking the offset of other side as well. Now we will proceed in the similar fashion for this side as well, measuring the distance at this point 1.4 mm, taking 1.4 mm offset again. Okay, so now we will move on to the other side, taking 3 mm offset, that is the general part thickness that was given to us. And now all we need to do is extend all the surface so that they intersect with each other, and then we will trim off to create corners of the B surface. Okay, so now we need to use the environment data. I will extract this surface in order to trim off the B surface. So we have the extracted faces now. We can hide the environment data now. And now we can simply trim off these extended surfaces of the B surface. So we need a 0.5 mm clearance between every meeting part. That same thing applies to the environment and our main part as well. We need a 0.5 clearance. That is why I've taken the 0.5 mm offset here. And now we can trim this. Okay. So this is our complete B surface. We have trimmed off all the extra edges. And now we can move on to the closing. So I will be creating a feature group for closing. Okay, make this active. So again I will be using the same offset surface for closing. Okay, so let's extract this. Okay. Okay, so I'm omitting the offset part because with that taking the offset we would have to trim the A surface as well, but we cannot make any kind of changes to the A surface. That means we cannot trim the A surface. So I will be using the extracted faces of the environment as it is. Just like this, without taking the offset, I will trim the B surface and then use it in the closing. With this we don't have to trim the A surface now, and now we can simply use this closing surface and trim the extra inside.